Okay, this is Math 9, class number 6, and as you can see, reflections and line symmetry is the topic. I'm going to start by looking at these shapes here. Now, symmetry, we did this way back at the beginning, was one of our concepts that we reviewed with those flags, looking at the line of symmetry on a flag. So line of symmetry, by way of very quick review, is where you can cut a particular shape into two equal parts. This triangle here, if you make a line directly through here, you will get a line of symmetry. I think I need to have a clear ruler to do this properly. Here it is. First, we're going to confirm whether or not it's possible for this triangle to have a line of symmetry. It's 1 centimeter, 1.6 centimeters here, and about 1.6 here. So yeah, straight through from this point here is your line of symmetry. The oval here, through the middle like this, or lengthwise like this. You could maybe do some diagonals as well. If we look at this shape here, obviously through the middle like this, and like this, and you could do a diagonal this way. This particular shape here has only the one line, straight through like this. Anything else doesn't really work. Same thing with this guy, the one line down the middle. This one will have at least 2 lines of symmetry, but I would say only 2. This is a cube taken apart. Well, I guess the top would be open because a cube needs 6 sides, but anyways, I digress. Here, I believe there is only one way, and that's if we do it a diagonal through here. That's assuming these 2 lengths are the same. Check very quickly. 1.8, and yeah, so we can do a diagonal straight through here. That's going to be a line of symmetry. This guy here, this way, and this way, right? And also that way. The moon, just split it across the middle here. That's all you're going to be able to do. This guy, I'm not sure if there is one. Measure the sides. 2, less than 2. Nope, I don't think you could get a line of symmetry. These 2 sides are unequal. This one and this one. Here we could have multiple lines of symmetry, and here for K and L. So the point is, you can get multiple different lines of symmetry depending on what your shape is, but the point is, where can the shape be cut into 2 equal parts? That is a line of symmetry. Let's have a look at some information over on page 354. And by the way, this was page 353. I may or may not have mentioned that. There we go. Felt like the camera was freezing, but it seems to be back in business now. Let's look at some of the information here on page 354. The pentagon ABCD has 1 line of symmetry, one you can see right here, because AG divides the pentagon ABCDE into 2 congruent parts, and nowhere else on this shape can you do that. Polygon ABCG, which is here, ABCG, is congruent, of course, to polygon AEDG. Okay. Also, each point on one side of the line of symmetry has a corresponding point on the other side. So point B corresponds with point E, and so on. Point C corresponds with point E, A, so on. Okay. Except A, of course, is your peak. The line of symmetry is also called a line of reflection. That's the next concept. If a mirror is placed along one side of the shape, the reflection image and the original shape together form one larger shape. The line of reflection is a line of symmetry of this larger shape. So reflection, this is a line of reflection, is where it cuts it in half. And so then you have two equal shapes. One is a mirror reflection of the other, and this is the line across which they reflect. Same with this shape here. There's your line of reflection. Now, looking here, how many lines of symmetry have we got? Just one, straight through here. Can't really, if I go here, this is the middle roughly. If you look, that's the middle. I can't really make a line through here that's going to cut through everything equally. It only works here because these shapes in the middle happen to be nicely lined up. Boom. But once I try and go this way, then I'm slicing. You can see, put my ruler here, you can see that this is going to be bigger than the bottom and so on. Okay. This shape here, however, has multiple lines of symmetry. Of course, we can do two straight. We can go here, straight, here, straight, and two diagonals. This way, this way. 4 lines of symmetry for this particular shape. Only one for this one. All right, we're going to look at an example on page 355. Using 0.5 centimeter grid paper. So we're going to make this shape, and then we're going to make reflections of this particular shape. Okay, so let me sketch the reflections of this shape to show you how it works. So you want to identify the triangles that are related to the red triangle by a line of reflection. Describe the position of each line of symmetry. Right? So, let's do a sketch. I'm going to double the size of these just to make them easier to work with. So the original red shape is a 2 by 2, but I'm going to go with 4. So and just, I'm not going to do a fancy job of shading it in, and the rest will simply stay plain. I want to have a black pin, but it doesn't matter. Just going to keep on going here. Let's start with shape C. Shape C is skipping 1 space, but I'm double spacing. So shape C, 2 spaces, and then I make it. So shape C was reflected over this line right here. See? It's the line of reflection for shape C. Shape B is right underneath, so that's easy. Straight down, straight up. So it was flipped over here. The line right underneath the triangle. Okay? Now we're going to look at shape A, which is 2 spaces across. We're going to go 4 spaces across. And where is the line of reflection for shape A? Right there. Would have flipped across this line and come over here. Let's flip across. Let's look at shape D. Shape D, going up how many spaces? Let's see. It goes across 1 space, so I'm just going to go across 2 spaces, and then it goes up how many spaces? 5? Well, 5 to its top point, so we're going to go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right across from C, and we'll make our triangle the same old 4x4 that we always do. And of course, the line of reflection for D is going to be coming through here on a diagonal. Okay, and let's just show you a diagram of this in the book here, give you a better idea. So they have this here. There's B with its line of reflection. Okay. If we look at shape D, it reflected across the green line right here. B reflected across the orange line. Okay. A reflected across the blue line. And for some reason they don't have a line for C. I don't know why that is, but whatever, doesn't matter. Oh. Messed up. Let's review. Let's really look at my drawing again. See, if we take this shape here and this, if we flip it, then the bottom is going to be up top. So C is not a reflection. You can't slide it up. You have to be able to flip it up. And if you flip it, then we have the bottom here, and this is the top. So C is not a reflection. All the other shapes there, like if you flip this, boom, this peak is here. If you flip this, this is here. If you flip this, it's here. But if you flip this, it doesn't work. C is not a reflection of the red shape. Should have mentioned that before. Good thing we checked their key there, right? Let's see. What else do I want to do here? Just going to look at a couple more examples. So we're going to sketch make a grid and sketch a shape. Then we're going to look at their instructions and follow up on that. So here I have my grid. Just going to number that. I won't double it this time. So this is at point A. Just follow along and copy. How many squares here? 4. Shape A, B, C, D. Now what are we doing? Whoops. Shape A, B, C, D. Now what are we doing with this shape? Let's look at the 3 things we're doing with it. A reflection in the horizontal line through 2 on the y-axis. A reflection in the vertical line through 6 on the x-axis. A reflection and an oblique line through 0, 0 and 6, 6. So what the heck does all that mean? Well, you're about to find out if you don't know. A reflection in the horizontal line through 2 on the y-axis. So 2 on the y-axis is going up and down is right here. Y-axis is vertical, so your line of reflection is right here. Okay. And flip it over. 2 squares here, 2 squares here. Done. There's a reflection over through line 2 on the y-axis. Reflection in the vertical line through 6 on the x-axis. Okay? 6 on the x-axis. So that's over here. 1, 2, 3, 4, 5, 6. Right here is our point. We're going to make our line go straight up. And there's a line of reflection on the x-axis, and we're just going to have to make our shape. A reflection and an oblique line through 0, 0 and 6, 6. So what's that mean? Well, there's a line that's going to cross through 0, 0 and 6, 6. Well, 0, 0 is right here. That's the origin of the graph. 6, 6 is 6 across and 6 up. 1, 2, 3, 4, 5, 6. Right here. So now we have our 2 points. And we'll just simply make our reflection. There's the diagonal side right here. Two up, 2 across, down. There's our new shape. Our new shape reflected over. So, there's your first one right there, reflected over 2 in the y-axis, reflected over 6 through the x-axis, and then an oblique line, or a line going on a slant with 0, 0 and 6, 6. You simply make your line and flip your shape. Okie dokes. Anything else we need to look at? No, I think that's good. Hopefully this is not too much of a jungle. Might be better if I'd done each one. You know what? It doesn't take that long to do each one individually. And just to clarify things, let's do it that way. Okay? So, there's one grid. Okay? We'll make our shape. Go across 2 and up 2, and very quickly make the shape. And here's your first one, going through the y-axis at 2. Y is always horizontal, and here is 0. So 1, 2 going up, like that. So there's number 1, line of reflection, y equals 2. Let's make another grid. Again, we'll put the shape. Line of reflection, x equals 6, 6. Going across on the horizontal line, 6 spaces, we make our line, and we draw our flipped over shape. And that's that. So this is where x equals 6. Horizontal is x, y is vertical. Let's go up top here. You got this? Let's go up top here and make our shape and our grid one more time. Cross 2, up 2. Zero, 0, and 6, 6. Again, this is 0, 0. The start, 6. 6, as you go 6 across, 6 up. You got your 2 points, you make your line, and now I simply flip the shape over that line. Now, the line, you can't just flip it straight, because the line is not straight. Okay? Hope everybody understands that. So here's the top part, where I'm simply going to have, okay, so here you're going to have the slanted side of the shape. So here we're going to have the side with a length of 2 and the other side with a length of 2. Those have to be here because if this is the slanted side, then the side that's 4 has to be over here. Okay? And you flip the shape over the line. This corner is now up here. Right? And this corner is here. And these two pretty well stayed where they are. Okay, 3 different reflections, or lines of symmetry, whatever you want to call them. They're both correct. So this is through 0, 0 and 6, 6. Your homework for this lesson, let's give you the exercises and then we'll look at them. On page 357, number 1. On page 358, 4 and 5. And on page 359, 10. 357, number 1. 358, 4 and 5. 359, number 10. Let's have a look. Sorry, that should say number 3 on 357. 3, not 1, 3. So, simply for number 3, which symbols have lines of symmetry, and if they do have lines of symmetry, how many do they have? So you either say they have none, or you give a number as for how many they have. Look at it carefully. Okay, that's number 3. Number 4, identify the lines of symmetry in each tessellation. In other words, how many do they have? This one's interesting. If you first look at it, it looks like the only one might be down the middle here, right? But look over here. There's 2 cubes on top, 2 cubes on the bottom, and these 3 can be divided up if you go straight through the middle on them. So just identify how many lines of symmetry each of these tessellations has. A tessellation is something made with multiple shapes of the same form. Number 5, on page 358. Copy each polygon on grid paper. It is 1/2 of a shape. use the red line as a line of symmetry to complete the shape by drawing its other half. So you take this shape, sketch it, make your line, flip it over. Just like we did with that last example, each one. Sketch it, there's your line, flip it over. Sketch, make the line, make the other shape on the other side, flip it over. That's it. That's all there is really to number 5. It's certainly not rocket science at all, I don't think. And number 10 on page 359. Identify the pentagons that are related to the blue pentagon by a line of reflection. Obviously D is. All the other ones you'll have to look at them carefully to see whether or not they're related. Remember the mistake I made back there when we did the example with the red shape where one of them wasn't related and I thought it was. I'm gonna guess there is one shape here that's not related. So there's some pretty obvious ones, but there's one that does not look like it could be related no matter where you put the line. Okay, just a very quick reminder about the 2 hand-in assignments for this unit so far. There was the enlargements, reductions, and triangles. That's a worksheet, 20 marks. And then there was, on page 352 of the textbook, the mid-unit review. And for that one, you were to do 1, 2, 5, and 6. And that one is worth 15 marks. Okay, so those 2 assignments should be coming in. Some of you have handed in the first one already. No one has handed in the mid-unit review as of yet. So make sure that happens. Stay caught up. You all know what math is like. If you get behind, it gets harder than it needs to be. Simple as that. Okay, that will be all for this recording. So, adios.